Hello everyone, we are down to our second to the last video for unit number 2. This video right now will focus on the practice exercise B on lesson number 3, which is still on the exponential equations. Again, I would like to clarify, we are just introducing the basic forms of exponential equations. There might be some exponential equations that will not be covered here. We will leave them for your higher level mathematics. Sharing to you right now is the screen of the Kotobee Reader application software, wherein I have already opened lesson number 3. In the previous video, we talked about practice exercise A. In this video right now, we are going to talk about practice exercise B, but still we are applying the same concerns that we did in practice exercise A. So I have placed these items in a paint software, application software, for us to make some scribbles and additional discussions and notes as to how do we solve this. Similar to practice exercise A, our goal here is to solve for the value of the variable. The value of the variable, in this case x, which will make the equation true. We are also going to apply the concept of the property of equivalent exponents, wherein if we have if we have two expressions with the same base and they are equal to each other, sorry, that b to the power of x is equal to b to the power of y. If we can express the both sides of the equation on similar basis, we could just simply cut the exponents out and declare that the exponents are also equal. And the essential part in solving exponential equations is to check. By checking, meaning you substitute what value you have uh, solved to the original equation and see if the equation will still be an equation. So let's start with number one. Number one is all about 3 to the power of 2x is equal to 1 to the power 1 over 81. Okay, so again, the goal here is to make sure that both sides have the same basis. Now, 81 can be expressed as an expression with base 3. Why base 3? Because your left-hand side of the equation is already in base 3. This case, you have here 3 to the power of 2x is equal to 1 to the power of 3 to the power of 4. Okay. Why 3 4 to power 4? Because 3 times 3 is 9, times 3, 27, and times 3, you have 81. You need 4 threes multiplied to each other to get 81. That's why you have that expression. Let me first remove these uh, numbers here so that we will have plenty of space. Now, let's continue. So we have here 3 to the power of 2x. And similar to number 3 of the previous exercise, we can bring it up. And since it's positive 4, we will make it negative 4. This is the reverse operation of the law of negative exponents. Not down that we have this, we have the same basis. Then we cut this out as our new equation. So you have here 2x is equal to negative 4. But we are not looking for the value of 2x. We are looking for the value of x. So from an exponential equation, we have now a linear equation. And I believe all of you are familiar in solving linear equation. Simply solve for x. Again, from an exponential equation, we have reached a linear equation and simply follow the operations in solving linear equation. So you divide both sides by 2 so that this will be canceled out. You also divide the other side by 2. So x is equal to negative 2. To check whether your answer is correct or not, you could always substitute negative 2 in our given. So 2 times negative 2 becomes negative 4. 3 to the power of negative 4 is an expression with negative exponent. You may bring it down. That's why you will have 1 to the power of 3 fourths and 3 fourths, 1 to the 1 over 3 to the power of 4, sorry. And 3 to the power of 4 is 81. You will still have 1 over 81. Applying the same thing for number 2. Let's have number 2 here. Number 2 is 7 to the power of x plus 2. Let's make it better. 7 to the power of x plus 2 is equal to 343. Now, we could actually express 343 as base 7. Okay? You don't know how? You simply try to multiply 7 by 7. You'll have 49. And multiply again 7 by 249, you will reach 343. So 7 times 7, 49 times 7, 343. In short, 343 can be expressed as base 7, just like the left-hand side. So we have 7 to the power of x plus 2 is equal to 7 cubed. Now that we have the same bases, we can simply cut the exponents and equate them using the property of equivalent exponents. And instead of a exponential equation, we will have a linear equation. So x plus 2 equals to 3. Subtract both sides by 2. X is equal to 1. So checking, let's try to check. Substitute 1 here. So 1 plus 2 is 3. 7 cubed is 343. That means our answer, our solution for x, which is 1, is already correct. And as for the last number, number 3, we have here the equation 25 raised to the power of 3x. Sorry for that. Let's make it better. 3x is equal to 125. We cannot express 125 as base 25, but we can express both sides of the equation as base 5. 25 can be expressed as 5 squared, and you still have the exponent 3x. Equals 125 is 5 cubed, because 5 times 5 is 25 times 5, 125. Now, we just need to apply the power rule here. So we have 5, you multiply, you have 6x equals 5 cubed. Why do we need to use the power law before the property of equivalent exponent? Is that there should be no more other operations here. So we are going to apply this. We have the same basis right now. So cut the exponents. You have 6x equals 3. Okay, 6x equals 3. Divide both sides by 6. X is 3/6, or in simplified form, 1 half. As for the checking, simply substitute 1 half in the given equation. So I'm just going to check number 3 only. So 25 raised to the 3 times 1 half. It should be equal to 125. So here you have 25, that's question mark because we still don't know. Raised to 3 halves, because 3 times 1 half is 3 halves. We don't know if it's 125. Okay, so we could convert this into a form or a radical expression form. We have here the square root of 25 cubed. Is it equal to 125? Since 25 cubed is very big, we could apply the other form of transformation of the exponents, fractional exponents, wherein we just simply say square root of 25 cubed, is it equal to 125? We place the exponent of the radical outside as the exponent of the whole. So square root of 5 is 5 cubed. Is it 125? So the final here, we have here the final answer, 125 as 5 cubed equals 125. Okay, so again, it's very important for us to check our answers so that we will be sure that our processes are all correct. I would like to repeat that one. That was a very good explanation. We need to check whether our answers are correct so that we could verify whether our processes are correct. When we try to check, we are not verifying only whether the answer is correct. We are also trying to check if there are some errors in our solutions. Because in mathematics, what is better what is more important is the process than just the actual answer. Because if you are going to familiarize and master the processes, then definitely later on you will be able to solve for the solution or the final answer. Right? Hopefully, this will help you in meeting other examples for exponential equations. You could use what you have learned here in your worksheets and prepare for the last video to be presented next time. See you soon. Goodbye.